C programming. C programming is used in software development, embedded software development, OS kernel development, and many more. C is used effectively in various specific domains, and it is free formatted language and efficiency and portability. Number system used in C programming are decimal, octal, hexadecimal, and binary. Data representation is in form of bit, byte, and word. Integrated number are positive and negative. Data types are integer, character, floating, and double. Next, we are going to see about conditional constraints. Conditional constraints consist of conditional statements which if else, if and switch case, and multiple iteration are done by loop, which is known as while, do while, for. And unconditional constraints are continue, break, which used to break the loop. Learn from C programming, and in which operators are used between two operands to return a value, and array, everyone knows that it's a collection of same data type, and address of the array are sequential. Pointers, parameter passing mechanism in function by passing the reference. Then functions, string, storage class are learned from embedded C. Then we are going to see about microcontroller. Microcontroller is an integrated circuit which is capable of being programmed to perform a specific task. And in microcontroller, all components in single chip, and which is less flexible, less design complexity. Things to be noted when using microcontroller are its application, performance, price, availability of tools, specific capabilities. This is the diagram of microcontroller. Then we are going to see about microprocessor. Microprocessor is a computer processor wherein the data processing logic and control is included on a single integrated circuit or small number of integrated circuit, in which all are separate components, more flexible, more design complexity. The difference between microcontroller and microprocessor are it consists in same in all the parts are consisting same chip, but in microprocessor it is separate parts, so it will be more flexible to uh, rectify the damaged parts. Next, we are going to see about embedded systems. Embedded system is a combination of hardware software which is intended to do a specific task, can be called as embedded system, in which there are categories: standalone, real time, and networked and mobile. And the challenges in choosing an embedded system are efficient input and output, and embedding an OS, then code optimization, testing, and debugging. These are the process and challenges in embedded system. Next, we are here. There are real-time aspects, where hard real-time, firm real-time, soft real-time. Next, installation of software and LEDs. Uh, we have installed the following softwares: MPLAB X IDE, PiximLab XE8 compiler. In MPLAB X IDE, we are going to create a X file, and we are compiling through XE8 compiler, and we are simulating our microwave oven project in PiximLab. This is what the process. And let us see a small project on LED. Interface LED introduction. Simple LED is the simplest device used in most on the embedded application as feedback. It just works like diodes. Then a basic program. Now the basic program is toggling of LEDs connected to port B of microcontroller PIC. And we are building an X file in MPLAB X IDE software. Then compiling in XE8 compiler. Then in PiximLab software, loading the X file with the board, PIC board, and a microcontroller PIC 16F877A. Okay, this is the basic program. We are using the PIC board and microcontroller PIC 16F877A. Then next, CLCD. In PiximLab, there is an yes, simulation. That is a display which is a consist of LCD which displays characters. That is what CLCD. CLCD is a character liquid crystal display. It has two type of display. They are 16:2 and 16:4. I will show it while simulation. Used to display ASCII character and symbol. It has totally 16 interfacing lines. These are the 16 interfacing lines, in which D0 to D7 are data lines. It has built-in controller. It has own RAM and ROM. The controller can execute instruction and data. In which RS is a register select line. RS value, if RS value is 1, it is data, and RS value is 0, it is instruction. And data processing in CLCD. Data processed in CLCD are two methods, that is delay method and pole D7 method. In pole D7 method, we wanted to continuously monitor D7. In data lines, we are providing data. Okay. Then if R by W equal to 1, it is means read. If R by W equal to 0, it means write. If R pin is permanently grounded, that means only write and data. Okay. In CLCD, D0 to D7 are connected to port D and RS, and the enable pin are connected to port E. In D0 to D7 are connected to port E, and RS and enable pin are connected to port E. Okay, and D0 to D7 are 8-bit function, and D4 to D7 are 4-bit function. Enable pin act as indicator by apprising LCD about the inception of data and data transmission by the microcontroller. Enable pin can act as an indicator by apprising LCD about the inception of data transmission by microcontroller. Then tactile switches. In matrix keypad, we need to configure rows as input, output, and columns as input. When designing pull down interface, R1 is 10 times greater than R2, which means R1 10 R2. And we are going to see about triggering methods, in which edge trigger and level trigger are there. Then bouncing effect, there is a metal plate and terminal, and spurious pulse detection while pressing or releasing the tactile switch is called bouncing effect. Okay. Then interfaces, there are two interfaces. We are going to see pull up resistor circuit and pull down resistor circuit. In which left side is called pull up resistor circuit, and in which right it is called pull down resistor circuit. While passing a signal to the interfaces, the output will be like as following. Pull up resistor circuit, when open, this gives 1, if press, this gives 0. If open switch state is open, in pull down resistor circuit, it will give 0. If pressed, it will give 1. Okay, this is the concept. So look at the interfaces. Okay, then we can look next. It's a matrix keypad, already seen in tactile switches. Matrix keypad used when the number of user input is required and still want to save the controller input output lines. Uses rows column concept, most commonly used in telephone, which is I will show weight simulation where is matrix keypad. In the cooking mode, matrix keypad keys are used to select the respective modes. Okay. Tactile keyboard, a key which is tactile, it has a bump on its response to finger pressure at or near the engagement point, where the key press registers and before the key buttons out and the end of its travel. Okay, next we are going to see about timers. Timers has 3 modes, which are PWM or pulse generator, counter mode, and PW and PP measurement mode. Then it has a function like tick, which we do up count or down count, and quantum function used in system clock settings, and scaling function is used in pre or post measuring, and resolution is register width, used to find register width. And in the microwave oven, we are going to use micro mode and grill mode are under the operational mode. Okay, I will explain while simulation. And the timer is set with matrix keypad, start to clear, and as to enter. While simulation, I will explain. To toggle the LED, 8-bit resolution is required. Okay, register associated with timer 0. These are the registers associated with timer 0. Where interrupt specifier indicates the function is an interrupt service routine, and it encoded specifically to suit this task. And microwave simulation using PiximLab software. Okay, I will first show the photos, and then I will show simulations. This is what PiximLab software. While go inside that you choose file and load the X file, and working of micro oven. If loading after the loading of X file, there will be a micro grill convection start. You need to select the option in matrix keypad. Let's select one. It is micro mode. Then set time using matrix keypad. I am setting 1 minute 3 seconds. Time setup, and time is running. We can resume. You can pause or resume, stop, anything. And if the time gets over, cooking time that will display in CLCD. cooking time up. This is what CLCD, but and its resolution type is changed in the left bar. And next I'm pressing 2 in the grill mode, and then next I'm setting the time. It's running, and it will end, and it will end like an it preheat and end like an okay, sorry, this is, and door closing intimation while pressing R2. While pressing R2, its door is open. Wait, I will simulate it, and so thank you. This is what PiximLab software. Now I am going inside. First, set uh, first, this is the interface. First set CLK megabytes equal to 20. Then choose file, load X. Here is what the X file we have done with MPLab software. I am uploading this, opening this. Now see, and this is running. Now see, micro mode, grill mode, convection start. Okay. Now I am using a matrix keypad. I am touching one. It is asking to set time. I am setting a I am setting 10 seconds, and pressing hashtag using matrix keypad. Then time starting, now start to run. Cooking time up, and at the end it will come cooking time up. Then we can choose, now we are choosing grill mode. Now I am setting time for 10 seconds. Now I am pressing hash to enter. It will show cooking time up. Next, convection mode. I am choosing 3. It's asking to set the temperature. I am giving just 27 degree, and pressing enter. Preheating time is 3 minutes. Let's wait for 3 minutes. Meanwhile, I will say that while I explain it, this is what the CLCD, and which it has in the left side LCD. Here it has its resolution. That is 2 resolution, and we are CLK. We are here use 20, and here board we can change our boards. I am using now PicGenius board. Okay, then microcontroller we have option to change, and here I have selected P16F877A. This is what the changes I have made. You can use any of the boards, while there is a debug, and this is matrix keypad. Here was port B, and port D we have already seen in the PPT, and this is what RB2 button, which is used when used, it will intimate the door is open. Okay, if preheating time is 3 minutes, we can wait for 3 minutes. The time is going. Okay, we can wait. After the time preheating, we need to set the time, and it will show the cooking time up. For the convection mode only, there will be temperature, and there will be a preheating mode. Almost 2 minutes is complete. Okay. Okay, now we are, it is asking to set time. Now I am setting 10 seconds using matrix keypad and giving hash. Now it's running. We can, okay, we can start or resume in begin. Once again, I will show how to stop or start. 1 minute micro and setting time for 20 seconds, and I'm giving enter. If you think it is wrong, you can if you want to pause, you can click file. It is paused. Okay. Okay, no, now I need to continue. If you can click 4, or if you it is mistake, you can click reset. It will come automatically to the first main menu. Okay, this is what the simulation we have learned in the EMERTX Institute, in EMERTX internship program. Then this is what RB2 button, sorry, RB3, it will choose, it will show. Wait, I will simulate RB2. Mistake, done mistake. 1 minute, 1 second. I have set 1 minute, 1 second. Um, Now I am going to enter. Now I am clicking RB3. See, wait, door states open. Please close. It will intimate when while clicking RB3. Okay. Oh, I want to reset. I want to reset it. It's the wrong time. While for showing to the function of RB3, I have just done this. So I am resetting. Okay. This is what the concept, and this is what the simulation we have learned from MS in Industry Institute. Thank you. Have a nice day.